ship left on the dock for more than 24 hours will be compressed to a cube at the owner's expense. Welcome to Sacred Cow Shipyards. Flooding in compartment 3, TAC 150, TAC 0, TAC Echo. Away the damage control teams provide from repair locker 3. Ooh, that's a mouthful, isn't it? So the good news is that this is a bad news, good news scenario, I suppose. The bad news is that there is a significant fraction of my audience who just dropped whatever they were doing, tried to reach for their boots, and tried to figure out where the Repair Locker 3 was in relation to them. Because, I mean, honestly, most of y'all listening to me are not on ships, and Repair Locker 3 is only something that happens on a ship. But the problem is, the rapidly ringing bell and someone saying flooding is one of those like pre-programmed responses into your squishy little brains. So yes, people were totally, automatically, autonomically, whatever you want to say, reacting to that sequence of inputs. So let me go ahead and say I apologize, but this is all for a point. So I'm sorry, but this will be educational. And as for the first good news is that your main engineering space, or your auxiliary 2 engineering space, I forget the numbers for the particular ship I'm trying to remember, but anyways, nothing is flooding for you right now. You're perfectly fine. Everything is fine. Well, no, I can't actually say that because I don't actually know where all of y'all are when you're listening to this video, so maybe something is flooding and maybe you should look into that. I don't know, man. I just record these videos. And the second good news is that if you had actually bothered to listen to a previous episode of this particular channel, you would know exactly where compartment 3, TAC 150, TAC 0, TAC Echo was, and what that compartment probably contained, and what you would be getting yourself into. Now again, I don't actually remember the numbering of all the compartments for various U.S. Navy ships, but the point is, shit floods. And fundamentally, flooding is bad. So what are you going to do about it? And yes, flooding is only technically relevant to wet water navies that are in, fluid systems that they put their boats and they try to make these boats into holes in the water, and the water wants to come in, and the idea is to keep the water out. And in space, vacuum wants to suck all of your atmosphere out. The atmosphere wants to go out as opposed to the water wanting to come in. But as much as those are different, similar premises apply. So we are actually going to take a minute and talk about how various navies manage their flooding problems, and then maybe you can reverse engineer this into how your interstellar vacuum navies can deal with decompression events. Or maybe you're idiots. I don't know. I'm going to do it anyways. So the first thing you have to understand, and I obliquely mentioned just previously, is that ships are holes in water. Water doesn't really like holes. It wants to go back into the hole pretty vigorously. But ships insist on being this hole in the water. And worse than that, these ships are not just holes in the water. They are holes that are taking in water in certain places and putting out water in other certain places, and it's making water very confused and very angry. You don't want water to be angry. We've had a conversation about how problematic salt water is. Salt water hates you. It hates metal things. It especially hates metal things that are moving. It hates everything that is not it. And you keep putting ships that are made of metal and moving things in it. Why are you doing this? Well, because fundamentally humans are idiots. We all knew this. We all know this now. It's all fine. But still, eventually, that condensed, liquefied hate is going to find its way into your ship. And now it's your job to reduce how much of that condensed liquefied hate comes into your ship, and preferably stop it, although that is kind of an ideal solution. So, say flooding gets called away in some engineering space somewhere, blah, 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 so on and so forth, and you determine that it is on one of the positive pressure sides of a pump that is pulling in salt water to feed into the desalination plant that is necessary to keep your squishy human beings drinking water that won't kill them. Fine, there's a leak. What do you do? Well, like I said, this was easy. You have a pump, and you have a positive pressure side, which is the side that the pump is pumping things towards. Turn off the fucking pump! Suddenly the pressure in the line after the pump goes to functionally zero, and you can address the hole in that line later when water is not like spurting out of it into your face. Cool. This is the easy answer. This is like the ideal flooding situation where things suddenly like spring a freaking leak somewhere on the positive pressure side of some pump somewhere, and you just turn off the pump. Because conveniently, pumps actually function as valves, and they stop anything else coming in after them. Most times. Depends on the pump. It's complicated. But still, most pumps work as valves. So yeah, secure the pump. Stop the water from coming in any further, and now we can patch this hole at our leisure. No big deal. Yeah. It's no big deal, except those kind of leaks never happen. You get the other kind of leaks. Because really, what happens if there's a leak on the negative pressure side of the pump, the side that the pump is trying to pull water out of? That's just the ocean. It's literally the ocean underneath your ship. And this pump is trying to pull that ocean up through this hole in your hull and make it do something useful. But still, there ain't no valve out there. That's just the ocean. And you have this pipe, and now there's a leak in it. Well, you can't turn off the pump, although I guess you technically could, but it wouldn't make a difference because, as mentioned previously, ships are holes in the water. Water doesn't like holes in it. Water wants to come into those holes. So now you have a pipe that is letting the water come into the hole that is your ship. What are you going to do about that? Well, if you know anything about damage control, you will deploy something called a Jubilee patch, or something remotely similar. It's all basically the same premise, but Jubilees have a name, and it's a fun name, isn't it? But I am actually getting ahead of myself. If this flooding is coming from like a source that is pressurized from on board, like it's like a drinking water line, and it sprung a leak, and now that's flooding this compartment, you don't need a Jubilee patch for that. What you need is basically a small piece of wood about the same size as that hole in that pipe, but it's like wedge-shaped, and you just shove it into that hole. And sure, that's not enough. And then you take twine or hemp small line and wrap it around and around and around and around the pipe and around that little piece of wood that you shoved into that pipe. And you keep wrapping until it holds. And the cool thing about hemp or any kind of vegetable matter line is that as they get wet, they swell. And all of that swelling action will take this spray of water and reduce it to just a very, very, very small drip. No big deal. And yes, this is legitimately your United States Navy's first pass attempt at sealing a pipe failure. If it isn't a significant pressure pipe, and I don't remember the specific numbers. No, it can't hold pressure. It wasn't designed to hold pressure. This was meant for like internal systems where we're like moving water around. And this is why you want your wedge to not obstruct the entire line. Because if you just block the line, well, then fine. You solve the leak, but now nothing downstream can get the water that it needs. The idea here, the primary idea, is to keep the water from being in places it shouldn't, while still allowing the water to be to places where it should be. And, well, it gets more complicated. And I guess that technically leads us to Jubilee patches. So like I said, the whole wedge thing was meant for like onboard water lines where something sprung a leak and no big deal. But again, imagine that you're sucking water straight out of the ocean beneath you and something breaks in the pipe before the pump. What you gonna do, man? And technically this kind of situation happens all over ships because nautical ships move water around rapidly at very high pressures. So these kind of Jubilee patches could be necessary at any given point in any ship, but it's always easier to break things down to simple levels, right? So, Jubilee patches. Basically, you take a flat piece of metal and you make it almost a circle, and then you like flange out the bits at the end. So basically you're making a C that has like massive serifs at each of its points, and all of it almost touches. And then you drill some holes through those serifs, and you put wing nuts through those holes. And then you put moderately thick rubber on the curve of the C. So basically, you take this weird band of metal and you slide it over this pipe. You pull open the opening of the C just enough so it just snaps onto that pipe. And yes, Jubilee patches are sized to fit certain sizes of pipes. And then all the while the water is just pouring through this hole you need to fix, you take this thing and you slide it up over the hole. And understand that hole could be letting hundreds of gallons a minute of really fucking cold water into your space while you're trying to like slide this massive metal clamp over this massive metal pipe with this, well, rubber gasket that we'll get to, and then slide it up on top of the gap. All the while being soaked to your very freaking bone with ice cold water. It's a very unpleasant experience. Anyways, Jubilee patches, yes, they are basically a wraparound C-clamp where you put screws through the serifs and you tighten it down, sure. But metal on metal is not a good seal, right? So these have actually like a rubber gasket built into the opposite side from the opening. So not only are you trying to like slide this metal gasket up around the opening, you're trying to slide this metal gasket that's trying to hold on to this rubber seal over this irregular freaking break in your pipe or whatever's gone wrong. And then once you get all of this in place, then you can start tightening down the nuts necessary to clamp all of this thing closed. It's absolutely nuts. You are basically building an external pipe around the existing pipe, and the interface is that rubber gasket, and you're cinching it down so hard and so tight that hopefully whatever broke that pipe, whatever angles and edges and so on and so forth, just get absorbed into that rubberness and it seals away. Again, the point for patching is not to necessarily stop the leak. It's just to slow the leak to the point where the bilge pumps can take care of it and the ship can get back to port and fix itself proper. You're literally trying to like bolt on this outside pipe to this original pipe just to keep the original pipe doing what it's supposed to be doing. It is the most sketch thing ever, but it works. Mostly because of that rubber gasket, and additionally because you're clamping a massive metal band around it. And to back up and talk about something that I kind of bounced off previously, yes, you do not actually apply the Jubilee patch directly to the leak. That leak could have a lot of force behind it. You apply the Jubilee patch to the pipe above or below the leak, and you put the wing nuts through, but you don't tighten them. And then you slide it up, normally using a mallet of some sort to encourage it along, over the leak. Because then the patch is basically holding itself on, and you're not having to force it over this massive water leak. And yes, the original Jubilee patch was made out of a single sheet of sheet metal, but there are actually patches that are hinged and are just literally these massive round clamps. And those are meant for really problematic pipes, and you don't want one of those to break. So, what happens if you have water coming into your ship and it is not coming out of a pipe? Well, that pretty much means you have water coming in through your hull. And that sometimes means that you're well and truly f***ed, but you might still have some options in the interim. So with pipes, our notion that we talked about previously, and if you haven't watched that episode, you should probably go back and watch it. There's probably a link in the upper right-hand corner somewhere in this video right now. Hopefully I'll remember to put it in. This is where compartmentalization is important. Because yes, for pipe leaks and such like, you can probably seal off the pipe. Depending on how big the hole in your hull is, it might just be better to seal off the space. Now, doing that introduces a whole host of other problems. Notably, are there people in that space? Is there equipment in that space? Can that equipment operate underwater? Typically, the answer is no. Also, now we get into matters of center of gravity, centers of buoyancy, and centers of something else that I forget, and I will probably talk about all of that in a later episode, although how it relates to starships, I have no idea, but it'll still probably be amusing to you. So, yes, if a ship got a gaping, freaking massive hole in its side, and hopefully its conditions were set right, then the correct answer is the compartment is sealed, we need to get back to port fast. But what about something that isn't a massive gaping hole? You don't want to have to write off the whole compartment just because you sprung a little pinhole leak. How do you deal with that? Well, unfortunately, there is no single answer. Of course, as you might expect, the navies of the world have found about 17 quadrillion different solutions to this particular problem. Because, again, water coming into the hole that you live in, bad. So I'm going to cover a few highlights, and maybe hopefully that will give you the right terms to go look up the rest yourself, because there's no way I am giving you an entire crash course in damage control right here, right now. Wish I could. Be kind of fun, but still, highlights. And in fact, it will just be 2 highlights, given how long this video has already gotten, and they'll be most relatable in my mind to the notion of keeping the atmosphere in your ship as opposed to keeping the water out of your ship, although for surface Navy, aquatic Navy ships, it's basically the same thing in the end. The first and most interesting, in my opinion, is that of a hook bolt patch. Yeah, it's kind of a mouthful, but it works really, really well in the situations where it works. And the important thing about both of these things I'm about to tell you about is they work for both flat patches and box patches. Now, flat patches are exactly what they sound like. They are flat sheets of metal with some sort of gasketing material on the side that you will be applying to the massive hole in your hull. A box patch is kind of the same way. It is a 5-sided box with one side open that has gasketing material around the edges. You naturally use one when the pokey bits are poking out, and you use the other when the pokey bits are poking in. I'm sure you can figure out which is which. So the hook bolt patches. These basically are used when the water isn't coming in too fast, but you want to stop the water from coming in anymore. So you take your patch, whether it's a box or a flat, and you drill a couple holes in it near where you think the edges of the hole in the hull would be. And yes, I know, it's counterintuitive that you're drilling holes in a patch. You then put a hook bolt through those holes and put rubber gaskets on the inside or even the outside of them and put nuts on the bolts. And then you twist the bolts so that they're all pointed to the inside of the patch. You shove it through the hole. You twist them again so that they grab onto the outside of the hull, and you tighten the little fuckers down. So yes, in effect, you are grabbing on to the outside of the hull and pulling your patch into the inside of the hull, courtesy of the hull helping itself out. It's kind of a funny idea, isn't it? But as long as the hole is not too big, and as long as it's not too, broken up around the edges, it works really, really well. And it's a good, quick patch that can hold up long term. So maybe sometimes simple is better. Well, I guess I should rephrase. It's a good quick patch that can hold up long term as long as there's not a lot of water pressure on the other side, or there's not expected to be a lot of water pressure on the other side. If there is, this will allow you to get a patch on quickly, and then you do the second form of interesting patching on top of this, which can also be done totally independently, which is why I'm talking about it second after all. And that is to say, you shore it. Yes, I did say shore, like the edge of the land right before it goes into the water. I have no idea how these terms happen to overlap in the English language. I'm sure there's a etymologist? I get those confused in ways that just bugs me to no end. Anyways, one of those can tell you how this happened. But anyways, yes, making a patch stronger is shoring. Well, shoring kind of complicated. The simple premise is that you have a patch, whether it is a box or a flat patch, and you have a hole. Great. You have no good way of attaching that patch to that hole. I mean, magnets don't work. Well, what else are you going to do? Well, you also got a stick. I wonder if we can, hold that patch onto that hole and take this stick and cut it to the right length and shove it between the patch and that bulkhead, that wall that is perpendicular from the hole in the hole, and it'll hold the patch on. And that's shoring. I mean, that's a gross oversimplification because I have to break this down Barney style for you guys, but still, that is basically how shoring works. You are literally taking a patch, taking a very big stick, and cutting it nearly to exactly the correct distance between the patch and the bulkhead opposite it, and then whacking in some wedges behind it to make up the difference. And all of that force then gets translated, the force from the patch that is, gets translated to the bulkhead behind it through the shoring. And the cool thing is, the way ships are built with what are called stringers on the inside of the ship, those strongbacks don't even have to couple into bulkheads or anything. You can put them into random corners and stuff, lock them in, and then use them to hold that patch into place. Now, yes, the whole wooden stick thing is pretty old. Most Navy ships still actually have wooden, they're probably 4x4s, to use for shoring. A lot of Navy ships these days have metal, adjustable length, configurable, blockable, interlockable, blah, 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 so on and so forth, systems that do basically the same thing that shoring does. Shoring is simply transferring force from the patch to somewhere else, because the patch cannot hold itself on. So you're convincing the patch to hold itself on by transferring whatever force it's receiving to the next available strong thing. And yeah, depending on how flooded a ship is and how dangerous the flooding is, because honestly, yeah, sealing off a compartment is the obvious, easy answer, but the internal compartmentalization of a ship is nowhere near as strong as its actual hull. So if you do actually have to write off a compartment, that is a temporary patch. You need to reinforce the walls, the bulkheads, between that compartment and everywhere else, which might require shoring. You're trying to distribute the load, and man, I got shown that meme recently, and now I can't get it out of my memory banks. Anyways, shoring allows you to use almost any rigid surface as a patch, which is basically why it's the coolest thing ever. It just requires some really complicated geometry and very fast cutting, which thankfully damage control men in your United States Navy are trained on repeatedly. And in fact, almost every U.S. Navy sailor has had some degree of damage control training. They actually have this thing called the USS Buttercup, which is not a theme park ride that you would ever want to take, but it really does teach you squishies just how terrifying it is to deal with flooding. And it shows you ways of addressing it, and it kind of reinforces how bad flooding can actually get. Now, I need to loop all this back around, right? Because in space, things want to get out. For nautical navies, things want to get in. But the difference isn't that great, because in space, things only want to get out at 1 atmosphere of pressure for you hummy, squishy things on your planet where you believe that the atmosphere at sea level is the only atmosphere there ever is. Well, conveniently, almost none of your warships draft more than 30 feet, which is about 1 atmosphere of pressure for water. Yes, if you were to swim down to about 33 feet, you would experience 1 atmosphere of pressure. Which kind of puts the whole, alien resurrection scene in a weird light. You know, the ending scene where that alien-human hybrid thing gets, sucked out this hole in the ship to the point where it's skull gets sucked out? Yeah, swim down to 33 feet. Does your skull compress? Well, technically it might just a tiny bit, but it's not going to fit through a quarter-sized hole. The hell? Sorry. Anyways, the point is, damage control in terms of hull compromises is much easier for vacuum type ships than it is for nautical type ships. Because in nautical type ships, stuff wants to come in really, really bad. And it's hard to hold a patch onto the surface that is keeping things out. For vacuum type ships, stuff wants to get out middlingly okay, and it will help you hold the patch on from the inside. Yes, you heard that right. If your ship gets punctured while you're in space, take something solid with an appropriate packing material on the backside and slap it down on the hole. The pressure of your atmosphere will hold it in place. That's how pressure works. Now, clearly, there are far better solutions than that. All kinds of gels and foams and all kinds of expandy things and energy fields and blah, 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 this, that, and the freaking other. But the point is, in vacuum transiting vessels, yes, the atmosphere wants to get out. So patching it isn't hard. You just need a plate big enough and a packing material air resistant enough and just drop it over the hole. And the pressure will hold it on. Now, yes, the trick is finding a gasketing material that is both air non-permeable and will seal whatever irregular hole that is. But really, it seems like y'all can figure that out. I mean, you have this crazy expanding insulating foam already. How hard is it to repurpose that stuff to work at 0G and to harden really, really fast when it's exposed to either vacuum or very cold temperatures? It doesn't seem like that big of a chemical change. And the doubly good news is that almost no spacefaring ship is just pulling in vacuum for reasons or whatever, like you squishies pull in salt water all the time in your ocean-going ships. So you've got fewer opportunities for the vacuum to want to let all your air out. But still, patching is basically a function of what side is the pressure on, and how can we get something big on the side that the pressure is on. Because if it's bigger than the hole, and the pressure's on that side, well, then the patch isn't going to go through the hole, right? Well, you can't always do that with ocean-going ships, so how do you apply more pressure on the other side? How do you apply more pressure on the inside of the hull as opposed to the outside where the water is? Well, hopefully I've given you some indication of how that is accomplished, and maybe at some point in the future we will revisit this topic in the future. But man, I have overrun my time, so, stop poking holes in things where you want to be. Seems easy, right? And that's all from Sacred Cow Shipyards. Please be advised that any ship left on the dock for more than 24 hours will be compressed to a cube at the owner's expense. Have a nice day.